what would have been different if we were doing part B instead of part A? What if I wanted parallel instead of perpendicular? What would I have done differently in this whole process? The slope would have to be different, right? The rest of the whole process would have probably been the same, but the step where we actually found the slope that we wanted would probably be different. If I start with this line y equals negative 5x plus 9, how do I find the slope of a line which is parallel to that one? For perpendicular, we had to take opposite reciprocal of negative 5. What would we do for parallel?
Well, you just leave it because it's parallel to it.
Exactly. Two lines which are parallel have the same slope. So we don't have to do any trickery, any magic, any flipping, any reciprocals, any opposites, any of that stuff. For parallel, we just take the slope from the original line and use it. So just to recap what that would have ended up looking like, part B, let me get rid of this box here for a second. If I'm doing part B, then instead of using 1/5 for my slope, what would I have used up here instead for parallel? Negative 5, right. And at that step, we've now guaranteed that the line that we're about to write is going to be a line that's parallel to the original. And then the rest of the process is completely the same. We would have just substituted that point, which also happens to be 3/6, into our equation. Use that to find a value for b, which is a little bit simpler in the parallel case because we don't have any fractions in our equation that we end up trying to solve. Instead, we get 6 equals negative 15 plus b. And adding 15 to both sides, we would have gotten b equals 21. Hope I did that right. And so if b is equal to 21, then our final answer there would look like y equals negative 5x plus 21. Let's put that into the graphing tool also just to make sure that we got what we were looking for. Y equals negative 5x, plus 21. Yep, sure enough, the line that we just found indeed looks parallel, right? It goes in the same direction as the original red line. In Euclidean geometry, we know that two lines are parallel exactly when they don't intersect anywhere. Right? Two lines are said to be parallel if they have no common point between the two of them. So these two lines are never going to meet. They're two roads that head in the same direction off toward the horizon, right, and never meet. And this line also happens to go through the point 3,6, which was the other condition in the problem that was set for us. So it looks like we did what we set out to do here as well.